Here we see the robot base, and by definition what we call the track is the distance between the wheel center lines. In this case it's approximately 122 millimeters for this EV3 driving base. If we desire to rotate that robot about its axis center line in a 360 degree full turn, this will scribe an arc that's 122 millimeters in diameter. We simply measured the distance between the wheel center lines and arrived at that figure. The circumference of that arc, that full circle, will be 383 millimeters, approximately. We may have to fine-tune these numbers later, but for now that's our starting point. So 383 millimeters is the circumference of that full circle turn that we have to make. That means each of the wheels, looking at a wheel now, each of the wheels must go around that full turn of the full 360 degrees. In this case, this is a 360 degree example. If one chose to do a 60 degree example or a 180, they would simply change the numbers and not do a full 360 degree circle, but just do the appropriate portion of it. So we have a 53 millimeter wheel. Circumference of each wheel, and there are two of them, is 53 pi, or 167 millimeters. So that means the robot, which we want to make a 360 degree turn about that 122 millimeter diameter circle, must cover the entire circumference of 383 millimeters. That means each wheel must go around 383 millimeters. So how many times must each wheel rotate? Well, they must rotate that full 383 millimeters around, divided by their individual circumference of each wheel of 167. So each wheel must rotate 2.3 times. Let's go ahead and convert that into degrees. Easy enough. 828 degrees is what each wheel must rotate to make the whole robot go around in a 360 degree turn. But we're going to do the wheels in opposite directions. One of the wheels is going to go clockwise, the other one is going to go counterclockwise, and then the robot should turn one complete circle. Let's go ahead and try it in LabVIEW with a real EV3 robot. So here we are in LabVIEW, and this block diagram in the lower left corner shows that the target device is currently the PC. Main application instance, and the fact that it's a gray box means this program, whatever we write, is going to run on the PC. Well, we would rather have it run on the EV3. Mine appears in the list. I'm USB connected. I'll just show you, if it were not there, I would choose Find NXT EV3, and then I would scan if it didn't appear in the list. So let me scan and give it a few seconds here while it looks via USB and Bluetooth, saying who's out there. Does it recognize any devices? Waiting very, very patiently. And sure enough, it sees Prof's EV3 connected via USB. And it is connected. If I disconnect, you'll see it's not connected right now. With that selected, I click connect, and poof, we're now connected. And close that. Now the lower left appears with the name of my EV3. It's called Prof's EV3 connected via USB. That's a beautiful thing. Let's bring up our functions palette. I just right clicked and chose functions. Currently Mindstorm Robotics is selected. I have choices of other functions for LabVIEW, but for robotics and for the EV3, these are the instructions I want. Let's do a really simple test. Bring in a move motor instruction. Actually, let's not do that. Let's bring in an advanced motor instruction. Motors, yes. Motors, advanced motors. Let's bring in a fixed distance instruction. And don't forget the context sensitive help. Control H brings that up, and whatever I'm moused over, that shows me all kinds of information about that. Here I see that the particular instruction highlighted has an option of specifying motors in the top, and also I can specify the distance and the speed. Distance is in degrees, speed is in percent of 100. First, let's specify the motors. Coming to the top, I right click and create a constant, and it put in this motor constant because it knows that I need a motor parameter type there. Let's click this to choose from the different motors. Large motor 1, 2, 3, or 4. Well, good question. Let's click configure, and it brings up yet another tool, the schematic view. It's called schematic editor, which shows my EV3 and what's connected to it. And I actually made these changes at one time in the past where it used to be a blank port like that, and I came up and clicked the triangle and said, well, the motor connected to port A physically is not a blank port, it is a large motor. So now that shows up there, and then I save this configuration, and it's beautiful, and it numbered these large motor 1, 2, and this other guy we're not going to use. Sensors are also shown at the bottom. That's what's currently connected. So once we're done with the schematic editor, we close it. I don't choose to save my changes in this case. So there we go. And I'm going to say large motor 1 is the one that I want to be driving right now. We'll do a simple test to begin with. Right-clicking on the distance input and creating a constant. It defaults to 360. I wanted, what was it, 828 degrees? I think it was. Let's say 828, and if it's some other number, we'll do otherwise. Then I right-click on the power input, create a constant there. Create a constant, and it defaults to 75%. Let's stick with that. That's perfectly fine. This at the bottom gives us the option to say, I don't know how long it's going to take it to go 828 degrees at 75% power, but let's wait up to some number of seconds. If you're not in a hurry, no worries. You can choose 10 seconds, 30 seconds. Let's just say 10 seconds, and there we have it. Next thing we need to do is test it. Notice that the run button and the run continuous button are not both there this time. Should be important to note that if I run it, choose the run button, it's going to download it to the EV3 and it's going to test it at the same time. So it's going to run as soon as I download it. On the other hand, if I want to just deploy it or download it, that's what this button is for. If I choose the deploy button, let's go ahead and do that. It sends it to the EV3, but it doesn't run. Why is that good? Well, if I have a robot with wheels and other things that are moving that I don't want to run immediately, I can just deploy it, and then I can run it by simply selecting it in the LCD panel on the EV3 and pressing the button. Let's go ahead and test this though. Let's go ahead and run it sitting on its back so the wheels aren't going to take this little robot anywhere. Downloads and runs. And there, I roughly counted the turns, and I think that was about 828 degrees. So there was a nice, simple example. Let's do this. Let's add our second motor. We need another motor. Whoops, that's not what I want to do. I want to choose the down arrow to add another motor. Notice two things. Notice it added a place for a second motor. Also, it added instruction stuff here for this second motor. I need to specify also the number of degrees. Let me say 828 degrees. Oops. I say that. Let me specify 828 degrees by just tying that wire there. And let me go ahead and select that motor now. Large motor 2 is the one that I want. And for the speed input, keep an eye on this now. It defaulted to 75%. Let me say instead negative 75%. So 75 for one, negative 75 for the other. That's what gives us the clockwise rotation for one, the counterclockwise rotation for the other. Let's go ahead and download and run this. I'm watching both motors. Sure enough, both motors ran in opposite directions, and it's a beautiful thing. That is pretty much the end of this LabVIEW part of the demo. Let's go to the live video demo. So let's go ahead and disconnect the USB cable. Unplug. EV3 is still turned on. Let's set it here on the floor. And let's put it right here. And that program should be currently selected. That's the one we downloaded. We didn't give it a name, so it's called Untitled 1. Untitled 1, I believe, is the name. So let's run that program by pressing the Enter button with that selected. Let's see if it goes in a circle. Okay, it went a little bit less than 360 degrees. Could be a few different things. Could be too much power for this surface. Not enough friction with the carpet. Let's try again. Not quite. And I also saw some overshoot at the end there where it was kind of sliding from momentum. If we go back and change the power settings, it'll be different. Actually, if I try it on a different surface, it will probably be different as well. Actually, that was about a perfect 360 right there. Pretty close. So I think that's as far as we're going to go with this demo. Point is, it works. You saw how it works. I would definitely do testing on different surfaces, especially whatever surface you're going to be demonstrating on. You want to be concerned about how well it does on that surface. Go back and change that number, 828 degrees, to something else. if you need to fine-tune it. Also, the power level being lower will cause less overshoot and less slippage and friction issues. So, there we have it. How to make an EV3 robot do a simple 360 degree turn, approximately.